Hey everyone. So the discussion for today's meeting is Zoom or Google Meet system design, right? I mean, be it Zoom, be it Skype, be it any audio video calls, right? So that is the purpose. Okay. You might have seen, you might have all used Zoom or Google Meet, WebEx, right? So these are the tools that are there in the system which are kind of used, right? So as we'll follow the template, right? How we had been following in our past discussions, right? So we'll go with the functional requirements first. So if we talk about functional requirements, right, one very basic thing is that we should be able to have one-to-one calls, right? Okay. Okay. Then group calls, right? This is at least bare minimum that we need. Okay. What else? It should have audio, right? Video, screen sharing should be allowed, right? Just see, I mean, we have all used Google Meet, right? We are there in that call itself, right? So what are the features that you kind of can think of that we need to jot down as part of the functional requirements?
Chat.
Chat, okay, yeah, we'll write the chat. There's recording, yeah, that's one, folks. There's so many features inside your Google Meet, right?
Raising hand.
You should be able to do all kind of CRUD operations on the meetings, right? You should be able to first create a meeting, right? Create a meeting, then let's say what, retrieve the meeting, correct? Then what, you can update the meetings, right? Can you not, like, let's say there is a meeting at this point of time, right? So you may want to update it. Essentially, it is not doing anything, right? The meeting link still remains the same, just that all of the participants in that calendar gets a notification, right? So I mean, this feature has nothing to do actually, right? So we'll just cross it probably. Okay. And what else? You can cancel the meeting or you can delete the meeting, right? Okay. Um, when you say delete, right, there is a link that can be what? Mm, that link which is created, right? I mean, let's say there is any metadata or the list of participants or anything that is to be done, right? All that can be done. Or let's keep update as well, right? You can probably inside that meeting entity, right, you can also update the list of participants, right? I mean, the way that you do in calendar. So let's say like,
Timing.
what do you do in a meeting, right?
Yeah, you can update the time, participants, add, remove.
Event, right? So you can add guests, right? Add the conference link, location, and all of that, right? So this is part of that meeting object, right? So you can update as well. So all the CRUD operations. What else?
Mm, Integration with telco. Like you can join with just calling a number, a phone call.
Okay, yeah. Join from multiple devices. One, okay, or multiple devices is one. Then join from what? Voice calls.
Voice calls, telco calls. Yeah.
What else?
Meeting summary, maybe transcription or summary.
Summary, transcription.
Raising hand.
Yeah, raising hand, yeah, emoji, yeah. What
Mm,
else?
I think Microsoft Teams, they have some kind of rooms which they can create so that some participant can go in a room,
Breakout rooms.
breakout rooms.
Yeah, record rooms, I've seen that, some recording. Okay, cool. So you have listed down all these requirements, right? Now, what else?
Voice to text subtitles on like live subtitle or something.
Okay, cool. Yeah, I mean, we can go on, right? But just what
Background,
we'll do is we'll probably limit. Sorry.
background. Like when you are
So,
video
yeah,
call, so you
yeah,
can change the
correct.
background. Like that is
Correct. You can all do that, right? So basically, our purpose here, right? Here purpose is that how does this work, right? I mean, these are some of the features. Yes, those devices are working, right? But let's say if you have to design by yourself, right? I mean, what is the MVP that the interviewer would be looking from you, right? Will go by that perspective. Okay. I mean, these are good to have, right? But let's say since we normally have 45 minutes, right? So we'll kind of keep them to be out of scope at the moment, right? All these requirements. Okay.
Okay,
In fact, we'll bring this chat as well out, right? And
sure.
we can discuss that separately as a item, another item. Yeah. Correct. Cool. Okay. These are out of scope items. What else? Now let's say non-functional requirements. It has to be what?
What's
Low
non-function?
latency, right?
Oh,
It has to be
yeah,
right. To
right.
be low latency, then what else? Close
That,
to real time, right?
Throughput,
What?
throughput.
I mean, see throughput. Um, I'm not able to probably. Can you just elaborate on it?
I mean, how many requests we can serve in a specific time?
No. So see, this is not a processing system, right? I mean, if you say bandwidth, right, then we can talk about it, right? So let's
Correct,
say,
correct,
I mean,
correct. Got it, got
right?
it.
So this throughput makes sense here.
Yeah, yeah, yeah.
Then it has to be real time, right? So we are okay with some kind of a data loss, right? Right? Okay. The communication has to be secured. What else? Durability of the recording. Let's say we call it 3 months. Okay. What else? Think of it. I mean, see, these are non-functional requirements are basically not the features, right? But these are not the functional. I mean, these are not the as a feature wise, but these are still required for you to for these are the things required for you for your app to function properly, right? When you have a lower bandwidth, right, lower internet connection, right,
Yeah,
you should
optimization
be able
based
to.
on
Sorry, go ahead, Vivek.
yeah, optimization based on bandwidth. Like if the bandwidth is low, then
Yeah.
the quality should reduce and vice versa.
Correct. So that's actually called transcoding. Okay. So you're saying basically, so let's say if I am, so normally you might have seen, right? What happens? So let's say I and Vivek are talking, right? Or through a call or anything, right? So let's say I have a good internet connection. I am on, let's say 5G and he's in a somewhere in a remote area, let's say where only 2G is accessible, correct? So now what happens is if I send 5G of my data, right? I mean, which is where I'm on 5G, right? So my video quality and audio quality and all of that goes very well, right? And what happens is his side, right, the bandwidth is not that much, so it won't be able to process, right? And you might have seen, right, at times we call it like when we are on a video call that please switch off the video so that at least we are able to get our audio clear,
Yeah.
correct?
Yeah.
Because you're sending less of data on that bandwidth, correct? Okay, so basically transporting is like, let's say as I said, right, if me and Vivek are talking, so my whatever the stream is going, right, it has to be downsized to meet Vivek's bandwidth requirement. Okay. However, since Vivek, what he's producing is already lower, right? So it need not, I mean, it cannot be increased. You can consider it like, see, a higher pixel image can be reduced to a lower pixel, right? But if a lower pixel image, if you kind of make it bigger, it will what do you call it? It breaks, right? Those pixels. So it's in that way. Okay. Transcoding conversion, or I mean, transcoding is actually a conversion. What do you call? What do you say? Higher to lower based on bandwidth users. Yeah. Anything else? Or shall we freeze this?
Yeah, hi, Pratik, is it recorded? I just missed the initial part.
Yes, it is being recorded.
Okay, thank you.
So just to iterate, right, for new folks who have joined. So basically, we are discussing the Zoom or the Google Meet system design. We have just covered functional requirements and the non-functional requirements. Some of the good to have features, right, but not necessarily important are these, right, which we have kept them to be out of scope at the moment. Okay. If I talk about the core entities, right?
And how many
So
people
we
it should
use.
support? How many participants it should support?
Yes. Okay. Correct. Yeah, this is also a good point, right? So let's say, I think Google Meet, right, as far as I know, right, supports up to 100 users or 500.
Okay.
Workplace supports 100 participants while paid supports 500. Okay. And enterprise offers 1,000. Okay. So let's say we supported only what? We support only, let's say, 1,000 parts, 500 participants. This is a good point. Yeah. By the way, this another thing that I can think here is we can talk about a bit on scale as well, right? How we used to do in our previous discussions, right? Since we are not doing a back envelope calculation, right? So if I talk about 100 scales, it would be somewhere 100 million daily active users. Okay. And what else? And let's say each recording, right? Each recording would be average 300 MB, right? After encoding. Okay. So, I mean, you can go and calculate how much of data would be required for 100 million users, and let's say 300 MB per recording, let's say, and we can go and do all that calculation, but seriously, I mean, that won't make sense. I mean,
How many meetings, I think, per day, roughly?
Yeah. Let's say two meetings per user, and you can do all of that, right? I mean, I feel that we can avoid that. Okay.
Got it.
So let's say users is this, right? Meeting, okay. Entity would be there. What else?
Recording.
Recordings will be there, right?
Part
But this will be part of the meeting itself, right? Somewhere. Okay.
I think meeting is more of a metadata, but recording itself is.
Yeah, correct. But I mean, so entity in the sense entity, right? I mean, see, meeting URL would be kind of a it would be a composition, right? It would have a meeting URL to it, right? If you're creating an entity table to it, right? Yes,
Okay.
yes, there would be a complete blob file that will be stored, but otherwise it'll
Then
be
it's going
inside
to
this,
do
right?
this one. Got it. Got it. Okay. Okay. Makes sense. Makes sense. Users,
Okay.
meetings.
Anyways, so we'll just leave this for now, right? I mean, if there is anything that comes up, we'll come back to it. Okay. Cool. So yeah, this is what we have at the moment. Okay. Now, okay. So now what happens is, let's say we had a WhatsApp discussion, right? Sometime back, right? I think Prashant had taken that session, right? So let's say this is he had talked about what? WebSocket handler, right? Okay. And what he talked about is, let's say two users are there, okay? Say two users are there. And, let's say they would be connected via this WebSocket handler, okay? And this is how they talk, right? Now, this WebSocket handler is a two-way communication, and this is based on TCP, okay? So since I've talked about WebSocket handler, I've talked about TCP, right? Can we go ahead with a WebSocket handler only for this particular case? I don't know. It's a little difficult, right? Okay, I'll tell you why difficult. Okay, but before that, right, I want to just recap, right, whatever we had read in our college, right? The basically the TCP and the UDP difference, right? So before I discuss like what would be the right thing to use and all of that. Okay, so this is very much important, right? That reliability is there, right? There is a three-way handshake that happens in case of a TCP, right? However, in case of UDP, there is no handshake, right? It's just a public IP is given between two hosts, and they send the packets. Okay, if you want to see the diagram, right? Can you draw diagram? TCP, UDP. Yeah. Okay, by the time Nano Banana does that, okay. Another thing is, see, this is a connection oriented, okay. This is connection oriented. So basically a handshake is required, right? However, if the client one knows where to send the packet to, right, it just sends it, right? There's no handshake that is required. Okay, this is important that it arrives in the same order, right? So basically the packets have some numbering to it, right? Some logical numbering to it, and they get delivered in that same ordering, right? You can consider that there is a pipe, right? And within that pipe, right, let's say packet one is sent, right? So what happens is the client basically says that, okay, I have received this packet, you can send me the other one, right? So basically after each packet, right, there is an acknowledgement that is happening, right? So you won't miss any of the packets there, correct? However, in case of UDP, what happens is, if any packet is lost, they don't care, right? They just don't care, and the discussion keeps on. I mean, the packet transfer just keeps on happening. Okay, I hope you're getting right. Just let me know if you don't get that. Okay, so see, this is what it's saying, right? It sends a signal, right? It sends here that yes, I've got your signal, right? And then it says, okay, I've got the acknowledgement that you had server that you had sent. I acknowledge that as well, right? So this is the kind of a handshaking here. However, in this case, what happens is basically just packet is kind of just sent from the client one to client two. This is not the right good diagram that I was looking for. Okay. Yeah. Okay, so basically it's a request, response, that keeps on happening here. Okay, and this is a unicast, this is a broadcast. Okay, and there are other features as well, which is Yeah, this is also important, right? That in case of TCP, right, there is an unnecessary too many bytes that are also being sent, right? Some 20 to 60 bytes header is only there, right? And in this case, it is only 8 bytes of header that goes in. Okay. And you can see use cases are email, web browsing, file transfers, right, where it is important that you do not want to lose the packets, right? However, in case of UDP, it is basically the, I mean, wherever you need low latency, right? I mean, live streaming, gaming, and all of those use cases, that's where it is being used. Okay. Now I said, right, okay, now we know what TCP and UDP is, right? So now what happens is, in case of WhatsApp, when we had discussed in our earlier sessions, right, there was a WebSocket handler, right, and there was a manager who was kind of managing multiple WebSocket handlers. So basically, what happens is this client was connected to this, let's say, handler, and this guy was connected to some other handler, right? And there was a WebSocket manager, and there was a registry, right? So that's how the connection was happening, right? But just see, right? See, if this guy sends to this, right, and then this, right, what happens? There is a lot of time involved, right? Okay. So if I give you an analogy, right? Okay. I mean, see, we have all gone through that college life, right? Okay. So what happens is, let's say, I'll give you an analogy. Like, let's say this is, I'll pick up some name. Okay. Okay. I think Shubham is there. He was my student. Okay. Hey, Shubham. So let's say this is Shubham. Okay. Okay. And he wants to, let's say, talk to some girl. Okay. So let's say some X. Okay. And now what happens is he wants to talk to this girl, and Shubham doesn't know her. Right. So what happens is Shubham says that, okay, she kind of contacts a friend of this X, right? Says, please get me her number, no, and or anything. She says, no, yeah, this is not right, right? How can I give you her number? Okay. So what happens is Shubham says, okay, then at least pass on my messages, right? That whatever. Okay. Okay, then she does this. Okay. And then, okay, let's say if there was feelings are mutual or whatever, right? And then this girl also says, okay, yeah, I want to talk to Shubham and all of that. They said, like, why are you guys involving me, right? You talk to each other directly, right? Just to avoid the latency. Correct? Okay. So what happens is, then ultimately, instead of this path, right, if somehow this path can be established, right, that would be the best. Sorry. Yeah. If somehow this path can be set, this is the best. No? Why do I involve the third person? Correct. So that's where we want to get rid of this WebSocket. Okay. But so this was just the phone number, right? But machines do not know each other's phone number, right? My machine or I mean, your laptop, my laptop, right? They are not connected by phone numbers. They are connected by IP addresses, right? Now, how do I get the IP address of this machine? Right? These were just the humans, right? But now let's say how do I get their IP addresses, right? So now there is a concept which I'll not go deep into it, right? Because I see the time as well. There are a lot of things that I need to cover, right? There is something called, I'll bring in a connector component, okay, which will help us, which will actually help us to, which will actually help us to get their IP addresses. Okay, I'll just copy the diagram from somewhere. Okay, I'd already drawn so that don't waste time. Yeah. Okay. So yeah, so basically what happens is this was a WebSocket handler, right? Okay. Now what happens is earlier our communication was through this, right? But then when I get the number, right, or the IP address, I will talk to this person, right? But I really cannot get the IP address directly, right? So what will happen is there is a component called connector, right, which will come into place, right? which will come into place and help this guy to resolve the IP address, right? And this will help this guy to resolve the IP address, right? Okay. So now what will happen is through the connector, right? The user A, right, will get to know its own IP address, and user B will get to know its own IP address. Okay. Now what happens is they can use this WebSocket handler to pass this initial information, right, to basically know each other's IP address, right? If the IP address is known, then what? We know that we can use UDP to send the packets, right? Sorry, I should not bring this right now. Okay. So any questions till now, guys? What is WebSocket handler? What is connector? Who are these guys? What are these arrows for?
When you say IP address, basically we need to decode, find the public IP address that can be shared across, right?
Correct.
Got it.
Right. So if you remember, right, your college, right? So let's say we used to live in a hostel, right? And what happens is we used to get internet from the college. So what happens is every basically users, right? Every person sitting in their room, right? They used to have what some IP which is like used to be called as 192, 168, and something, right? What this used to be? This used to be a subnet mask, correct? Right. Now what happens is when somebody wants to talk, right, I mean when these packets have to be sent, right, there is an IP that is given to an institute, right? But there would be some kind of a NAT device, right, network address translation device, which would tell you that this user A has a device, has an IP, let's say 38 dot or 8.12.15 or whatever, right? It has an IP dot. Let's say if he's connected on, let's say, port P1, this is connected on port P2, and this is, let's say, connected on port P3, right? These three users. So ultimately, what my public IP for this user A would be is, let's say, 35.8.12.45 with port P1, something of that sort. Okay. So this connector is the one who is actually helping realize their own IP addresses, and these guys are kind of sending the messages through this WebSocket handler to know that, okay, these are my information. When you want to send me the packets, you can send through this. Okay, cool. But then what happens is there are at times, let's say if they are geographically far, okay, let's say I'm in India and there's somebody sitting in US, right? So what happens is now this peer-to-peer communication won't be really feasible, right? And there can be higher data loss as well. Okay, so that's where what we can do is, since we do not have an option, right? I mean, I know latency is a primary thing, but accuracy also does matter, right, to some extent, right? I really don't want to just jeopardize my calls just because I want lower latency, right? So what happens is, in that particular case, I'll be bound to bring in something called some kind of a server, right, through which now this communication won't be direct through this, right, but let's say through a media server, right? But if I give you an example, right, let's say if this was Shubham, right? So now let's say they are let's say he has gone for his MS, and then let's say his girlfriend or is in India. Okay, so now what happens is, let's say ISD calls are very costly, right? So what can happen is there is another way that he can choose to, let's say, through post itself, right? He can actually send this, right? Because what happens is, I mean, I'm just giving this examples just to have an analogy. Otherwise, you can understand whatever example suits you the best, right? So basically, this media server is just an enabler, right? Because these two what I call communication paths are really not working, Okay, so then it goes through a media server, and then that's how the communication happens. Obviously, this will be little slower. Okay. Just to make it complete, right, I will add two more components which we had discussed when Prashant had taken that session, right? He had taken what? WebSocket Manager was also there, right? Which is, so this diagram may not be depicting, but it may happen that this guy, right, is actually connected to this WebSocket, right, to one instance, and this guy is connected to some other instance, right? So there has to be some kind of a manager who is actually managing these instances, right? So let's say if A is sending a message to B, and then this guy, since B is not connected to the same instance, so this WebSocket handler will say that, okay, WebSocket manager, tell me where is B, right? Give me the details of the other instance, right? So this WebSocket manager will enable to send a message from A to B. Yeah. And this connection registry is basically manager also will have to store, right? Where is A connected, where is B connected, right? The connection, right? They're persisting a connection, correct? So all that. Okay. I know this might be a little overwhelming, guys, but this is something called WebRTC. Okay, this is web real-time communication. Okay, this was developed by Justin Uberati. Okay, he is currently when he was with Google in 2011, right? And this guy, and along with few other people, right, he developed this protocol, right, which was based on UDP, right? But it's a mix, right? It's a mix. It's not completely UDP, but primarily UDP. Okay, I mean, see, none of the protocols are kind of completely TCP or UDP, right? They are TCP or UDP are the transport layer protocols, correct? Okay, but let's say if you talk about Quick, right? This is also a mixture, right? The new protocol, if you have heard of, right? If you have seen Byte Go's videos or all of that, he talks about this Quick, right? So this is also actually UDP, right? But little what I call the losses are lesser here. Okay, I mean, you can go deep into it, right? And like, let's say if you talk about HTTP, right? I mean, it's not a transport layer protocol, right? It's an application layer protocol. It is developed on either TCP or UDP, right? There are multiple versions of them, right? One is like HTTP 1, HTTP 2, then the latest one is actually HTTP 3, right? Which is on Quip, right? So you can read about all of this, right? But the base, right, the underlying, right, is basically the TCP and the UDP, and there are some tweaks, right, based on which what I call these protocols are kind of developed. So WebRTC is also one. Okay, any questions till now, guys? Okay, so now this is what I kind of dig deeper, right, into WebRTC, right? But all this comes as a protocol, right? And this is like, if I just put it here, right, there are what I call terms given to them, right? So this is basically called signaling server. Okay, this is called a stun. This is called a turn. Okay, I really don't know what their what I call full forms are, right? Stern in WebRTC. Abbreviation. Session traversal utilities for NAT. Okay, so basically what this connector says is it is a standardized protocol used to help devices locate their NAT, right? Like your home router discover discover their own public IP address and port they're accessible to. Why is stun needed? Okay, I will not go deep into it, right? But come back to this, right? What did I say? Basically, this stun is actually helping you to find your own IP addresses. Okay, so what I'll do is I'll basically just paste the definition and or probably the abbreviation as well. Okay, letting the device to know their public IPs. Okay, cool. Then this signaling server, what was this doing, right? What was this doing? Signaling server was basically helping these clients to exchange the what? Not the calls, but some kind of information, right? Like what is my IP, what is my bit rate, and what is my what do you call bandwidth, right? What should be the resolutions, what should be my cryptographic keys and all of that, right? So this is the signaling server, right? Signaling, is there something called signaling server in what? WebRTC?
So these are basically some system or like it's an available tools in the market.
So
System and
this entire component, right? So this entire component, right? I mean, if you want to read about WebRTC, right? You can actually look into this Nasir's video, right?
Okay.
By the time this loads, right? So what I'm trying to explain is, right? Hussein Nasir's video, right? I mean, this will help you. Okay. I mean, see, why are we discussing this, right? I mean, any one of us can get this problem in our interviews, right? And if you really do not know these underlying things, right? Since not everyone can work on all of these technologies, right? Or you might be working something great, but interview doesn't care, right? I mean, he will be judging you on this problem itself, right? So you also have to know this, right? So WebRTC, right, is just a protocol which is developed on the underlying is basically UDP, right? And there are other things as well that are involved. So the entire component, right, this component is actually called WebRTC. Yeah, understood, Gautam?
Yeah.
Yeah. So the signaling server, right? So what was the signaling server doing? Signaling server, there are some use cases like, just copy them here. Okay, basically the exchanging of the information through a WebSocket handler, right? Then bandwidth information, cryptographic keys, right? And this transfer happens via the protocol called SDP. Okay, now what is SDP in WebRTC? Right, SDP basically states that session description protocol, right? So basically what happens is all this information that was going through this WebSocket handler, right? This is going via protocol which is called SDP. Okay, I mean, these are something which if you call out, this will be helpful, and yes, it is important. If you're understanding WebRTC, then yes, it is very much important. Any questions till now, guys? Okay, we'll move on then. Okay, so just a recap again, revision. Okay, so basically there are two people, right? They want to talk to each other. Yes, they can involve a server. and talk to each other like we do WhatsApp, right? Our messages do not go directly, right? When I send you a message, it doesn't go directly go to you, right? It goes through a server, and server says, okay, well, it talks to manager, where is this guy connected, the other guy where to whom I want to send a message, right? So that's how this WebSocket handler comes into place, right? Which in terms this entire thing comes as a packet, right? As a web RTC, right? As a protocol, okay? Uh, and all of this is taken care internally, okay? Then this connector, which is actually called a stun. If you don't remember, you can call it a connector, right? Which actually help us to get the public IP addresses of this, right? And if these guys are geographically very much apart, right? Or if they are blocked by the firewall, right? So then what happens is one user cannot directly communicate with the other without involving a media server, right? And this media server, right, what will really happen is the example that I shown you, right, in the hostel thing, right? So they are not directly talking to each other like this, right? They cannot directly talk to each other through through router IP addresses, okay? Then because the college might have enabled some kind of a firewall or all of that. So that is one case. Otherwise, if they are geographically distant, then also they'll have to go via the media server. Okay. Now, okay, so you understood when it is about two people, right? But what about group calls? That was also one of our functional requirements, right? So when I say group calls, right, when four people are talking, right? Okay. Now, when I say peer-to-peer, right, or let's say just an example here, right? When I'm talking about peer-to-peer, right, I'll just copy the diagram just to guys. We are having these sessions for past 2 weeks, so we are kind of evolved, right? We know what saves time, so that's the reason we have just created some diagrams which helps us to. Let's see, this guy is handicapped or no, we'll replace them. Okay, so what are these arrows? Okay, so it took me some time to draw these diagrams. So basically what happened is this guy is actually sending messages by one from his own laptop, right? With a peer-to-peer message, this red arrow, right, which is coming from this guy, right? So this guy is actually colored red as red. Okay, so this guy is sending red on a red channel, let's say. Okay, so he will have to not manage connection, but he'll have to know the IP addresses of these people, right? Okay, and this guy is what? This guy is kind of sending green data, right, from this guy to all the other four participants, right? These are only four. Let's say if there are 100, then this guy only will have to manage to will have to take care of sending the stream packets to all the 100 members, right? This guy is sending what some yellow packets. Okay, and this guy is sending, let's say, some blue packets, right? This is how the communication would happen. Now, if you say 100, then it is not feasible, and that's not how it works, right? So there is a configurable limit, right? So let's say we all are in a let's say same company, same meeting room. Let's say if there are 10 people also, it's okay with this topography, right? With this mesh kind of a structure, right? But if these guys are geographically distant, right, then what happens is then this may also not work, right? And what we may have to come up to is we may have to bring in the media server. Okay, and how that would look like? That would look something like this. This is the same that green guy. Sorry, I think the arrows are mixed. Okay, anyways, look at this. Yeah. So now what happens is this guy will send to media server, and media server will take care of sending to the other all the other participants. Are we clear, guys? when this guy sends, right, it is only sending to this guy, media server, and media server is actually taking care of sending to the other three people. Right? What was happening? This guy was actually sending the same packet to three people, right? If the bandwidth requirement here is n, right? This was, sorry, let's say if there are, let's say n people, right? This is four people. So n is actually four, right? Okay. So now what happens is if he sends to one, so then it is only n bandwidth, right? But normally what is happening is every user is actually using what? N minus one bandwidth. Three times of what should be used, right? Again, this guy is also doing this, right? So that's why I said, like, if when it grows, right, when it grows to 100 people, right, then you are actually whatever the data you have to send once, right, you are actually sending, let's say let's say you are sending like 3 kilobytes of data, then you're saying like 3 into 100 kilobytes of data, correct? So that may not be very feasible, right? So then we'll have to come to this structure. So this can be configured and it can be dynamic. Let's say we decide, okay, if n is equal to 10, then we will fall back to this, right? If n is equal to 6, then we'll fall back to this kind of a structure. Obviously, this is faster, right? But there are some trade-offs between these two. Cool. Yeah. Okay. Then now we'll come to the HLD here. Okay. Oh, sorry, we did not discuss the APIs, right? Yes. Sorry, I got flown away by WebRTC. So, guys, this is very much important. WebRTC. Take a screenshot or whatever. You can watch the recording, whatever works, right? Wherever you want to read it, but go a little deeper. At least spend 15 to 20 minutes understanding what WebRTC is. Okay, since I've explained this WebRTC, I will talk about another protocol which is called RTMP. Okay, now why am I pointing this is just for the reason that, see, ultimately it's either TCP or UDP, right? But difference from use case to use case, right? When you are watching a cricket match, right, on Hotstar or whatever ESPN or whatever your this thing is, right, provider, in that particular case WebRTC doesn't work, right? WebRTC works for peer-to-peer communication where none of them is kind of a primary, right? But RTMP is a kind of a protocol. You cannot use WebRTC there. Okay, RTMP is another protocol which is based on TCP, and here what happens is there is some kind of a primary, right, where the cricket match is being broadcasted, right? So let's say I'll say Hotstar. Okay, this is Hotstar, and there are multiple clients to it. Right? So then in that particular case, right, you would use RTMP. Okay, so see, it depends all from problem statement to problem statement where you have to use what. Okay, so do not confuse. So if you're given a problem like, let's say, design a Hotstar or anything, then RTMP won't be used. It is, and why it is, and let's say, can you, if I talk about another example, right? I was talking to somebody, can I use it like while I'm watching Netflix, when I'm designing Netflix? No. Why? Because this is a real-time data, right? This is a real-time data, right? In case of Netflix, right, there is something else. The recordings are already there, right? When you're watching some YouTube video, they are already encoded, and the transcoding and all that happens on the fly, but encoding and all that already has happened, right? So there is already there is altogether a different protocol. Just see, right? I mean, how from one problem statement to another problem statement, the protocols are kind of changing, and you cannot use one fit for everything. Clear? Any questions, guys? Is it becoming overwhelming or anything? Yeah. Okay, cool. So this we understood. Okay. Somehow after core entities, before discussing this WebRTC, right, we should have discussed APIs as well. Okay, what are the APIs that would be used? Okay. So this is a functional requirement here, correct, on the left, right? So what would be the APIs that would be required? One is if I go with the CRUD, right? If I go with the CRUD, I would need create meeting API, right? And that would be what? Some kind of a post API, let's say slash meetings, right? And there would be some kind of a this thing, body, right? I mean, what do you require? You need what? Some kind of a link, right? In either it is in case of Meet, it is a link, or in case of a Zoom, there is an ID, right? Or what else? Participants, right? Time and all of that.
ID will
Okay.
be the response, right? Not in the body. When it
Correct.
will
I mean, this would be a response.
like when you trigger the API, when the meeting is saved, then an ID will be generated.
Correct. I mean, that would be an update call. Yeah, this would be a participant, right? Time and all other metadata that you want to send. We had seen that already, right? Well, from the calendar when we were creating. Yeah. Okay. What other API? We'll have to do a this thing. Get meeting details, right?
Right.
Which is a uh, quickly write this get, right? Get and let's see what slash
Meeting
things.
ID.
Yeah.
Yeah.
What else? Update. I'll not go into update. Okay. I'll not go into cancel as well, right? You can use the delete part of it, right? Delete and slash meetings and or let's write this here. Let's delete meeting, delete or cancel meeting. Okay. So let's say delete meetings slash ID. See, this one is actually get and this one is delete. Okay, this is the HTTP methods. Okay, so the signature can be same here. Yes. Yes. I have to what? Start the meeting, right? Start or end the meeting, right? For them, the APIs would be there. Just show this. So let's say start. Okay. For start, I would say post and slash meetings slash ID slash. Okay. I hope you guys know why am I writing start at the end and why ID, right? So these are some API conventions that should be followed, right? I mean, I'm not saying this is completely correct, but basic ones. Okay. Okay. Then similarly, we can have another endpoint. Let's say end. Okay. What else? We have created the meeting. We have get start the meeting. Okay. This will be done by the host, obviously. Okay. And let's say you want to join the meeting, right? So let's say in this meeting itself, right? I was the one who kind of hosted it, right? So I started the meeting, right? And now if you guys want to join this, right? So let's say there would be some other API, right? When you say Google Meet join, right? So then what happens is there is again another post call which is made. Let's say it's called meeting slash ID and slash join. Yeah. So these are, I think, at least basic APIs that we would need, right? We can add more, right, from this, but yeah, this is fine for now. Okay. Cool. Yeah. So now we'll come to the HLD diagram now. Okay. Yeah. So I'll just save time and copy this. Okay. Yeah. Now, this would be a high level diagram. I have not done anything, right? But have just replicated this same thing here. Is it too big or too small? Just let me know, huh, guys? Right? This is the same thing which we have drawn the WebRTC thing, right? I've brought this here, the HLD diagram. Okay. So this is a WebSocket handler. Okay. Yeah. Yeah. Okay. Now, so what we had was there as okay. Let me get this rid of this as well. Now, what we see is we had a WebSocket handler. We have a WebSocket handler, right? There can be multiple instances of it, right? That is the reason we need a WebSocket manager. Okay. Then there was a connector. Yes, there is a connector, right? There can be multiple media servers as well, right? If we have to scale, right? There can be multiple media server instances, right? So that is the reason I have drawn these multiple boxes. And what happens is, in order to manage them, right? Either you can call this as a media server manager, right? Or you can call this as a broker, right? I have taken this terminology from like Kafka's this thing, right? So whatever you call it, I mean, it's up to you. Okay. Now, another service that we would require here is basically the meeting service. Right now, what happens is this meeting service, all these APIs, right, which we had seen here, create, update, get, delete, start, and join, right? All of this would be kind of through this. Okay. And yes, we will require some kind of a database for it, right? So let's say yeah, this is a meeting database. Okay. Cool. Yeah. Yeah. So now, what else? We had some requirement for recording as well, correct? Right. So now
That
when
based
we
on DB.
yes, I think we missed that, right? So see, these guys are talking to each other, right? Now let's say if I say I want a recording, right? Where should I store the recording?
Blob
Here, here, here,
media
here.
server.
Yeah. So that means if recording is required, then we will have to involve a media server, right? Otherwise, recording is not possible. Yeah. So in this diagram itself, we can also say that yeah. And we'll replicate the same here as well, some kind of a service, which is, let's say we call this as a recording service. Yeah. Okay. Now this recording service, what is this really basically doing, right? It is only catching the streams, right? Multiple streams with timestamps, right? With particular timestamps that are coming to it. Correct. Now, what it has to do? I mean, when you end this meeting, right? You don't directly get the meeting, right? You get it after some time, right? So what we can probably have is some kind of a, let's say, a distributed storage, right? which we can bring in, right, and store this recording here. Okay, now we have stored some kind of chunks, right? Some chunks, some logical chunks in these. Okay, now what happens is, when is the file has to be created, right? The entire file has to be created out of it, right? So then what would happen when the file would be created? It's basically when the meeting ends, right? Only then, correct?
Or
So
somebody
that
stops
means,
the recording.
no, I want the file basically.
Like if you click
I want the file.
stop recording, then also it will just accumulate all the chunks and
Correct,
create.
correct. Makes sense. Makes sense. Yeah. So yeah, you can probably have another endpoint then. Yeah. Apart from end, let's say stop recording or something as one kind of a trigger for it. Okay. So what can happen is, let's say this is Kafka here, right? Okay. And we have, let's say, some kind of a topic. Say we call it as create recording or create file, whatever you want to say. Create recording, right? And this will have to be consumed by some service, right? Let's say call this as a file creator service. Okay. Now this will consume the message here, and then it will pull from here, and let's say all that, and probably I'll not go deep into it this, right? You can use some kind of a Spark job or something, right? To create a what file in the S3. Yeah, for the recording file. Yeah. What else?
Shouldn't it be instant that create recording? If we put it into some kind of queue, then the meeting
No,
recording would be
it's not. It just trigger. It just trigger saying that file creator service. Now you can start the recording for this meeting ID.
So it should start then and there, right? Like it should not be an async thing, right?
No, I mean,
Generally,
is
if
it
we
really required?
no, if we generally put some queues like all these topics, right? So it is for generally async processing and but when we say like okay, start recording, it should start immediately, no? Should we
You are saying instead of
Yeah,
Kafka,
start
you just
recording.
make an API call. Is it what you are saying?
I'm
No,
thinking
no,
like
no, 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 no. Wait, you misunderstood that. So this is only for create file, basically the recording file. The chunks were already created here.
Okay. So basically, okay. So
The
probably
final file.
what we should do is like, okay, when we click the stop recording, API will stop the recording and put an event, and that async processing should
File
take that storage and create the file. Okay, makes sense.
Yes. Yeah.
Okay.
There are multiple chunks stored here, right? This will kind of see with this meeting IDs, collate them, right? Probably arrange them in the timestamp order, right? And then create a file out of it.
Yeah, makes sense.
No. See, one-to-one calls we discussed, right? Group calls we discussed, right? Audio, video, right? Screen. So basically, when I say audio and video, right? So what really happens, say guys, you have to understand, right? It's not the entire thing goes together. Okay. See, what happens is there are multiple channels between them. Okay. So what happens is audio packet goes differently, video packet goes differently. Video, when I say video, it's a it's a video packet, right? If I say screen sharing, right, that is also a video packet only, right? Correct. So they go by the timestamp, right? And what happens is the client machine, right? Okay, basically your browser, right, it actually takes all of those packets and then shows you a complete thing. So you are hearing my voice and my video, right? They are actually two different packets, right? But your client is actually showing me that at the same point of time the audio and the video is getting played. It's like when you watch a movie, right, the subtitles and the video part of it, right, they have to be aligned.
Correct.
Correct.
Mm.
Yeah, so that's how it is. Okay, the recording we discussed about these APIs, right? Low latency we discussed about, right? The peer-to-peer communication, right? Data loss, since we are using UDP, right? So data loss is okay, I mean, is okay. Okay, secured communication, right? So what happens is it was through the signaling server, right? The secured communication, what do you call, keys would be transferred, right? And when they are joining the meeting ID or anything, right, all of that tokens, right, are transferred through the signaling servers. Okay, durability, yeah, the recording that we are storing, we have to, let's say 300 what 3 months, right? So we can calculate how much of database that size that we would require, right? All that calculation, it would be in the order of, like, let's say what 100 million into what, let's say one file is what 300 MB, right? Okay, and let's say 100 million users on an average are taking, let's say, on an average 3 calls per day. Correct, correct. So then this is the per day approximation.
Mm.
Correct. This will be what, 100 million, meaning 10 to the power of 6. Right?
90 GB.
It will be somewhere in the petabytes.
Oh, no, not
Okay.
GB.
Let's
90,
GB.
90 million.
Yeah, okay, leave it anyways. So it'll be some petabytes, right? And let's say if you want to have it for 30 days, right? This was only for one day, right? For 30 days, it is this, right? For that means 1 month, right? That means if you want to make it for 3 months, then this would be the calculation. So this much of the storage is what you would require. Okay.
But I guess
Then
when
transcoding, right? Yeah.
I guess when 100 million people are taking 3 calls, then it's like the call, like if 2 people are on the same platform, but the recording is only one. So
Yeah, I mean, this is just an approximation, right? I mean, we just took 100 million users, right? So this is just a approximation. When I say 100 million, it's like same 100 million recordings are kind of somewhere happening.
yeah, but
This is just this will be with buffer. Yeah. Transcoding, right? Why we have written transcoding here? What is transcoding? What is encoding, right? Encoding is basically what happens is, see, when you kind of upload your video or anything, right? Encoding is basically all that compression and all of that, right? Is basically encoding, right? What is transcoding? Transcoding is basically adapting to the bit rates and all of that, right? So let's just Google it, right? Because these are very confusing terms, right? What do they do? Right? Encoding actually works on the raw data, right? Okay, okay, and for this is basically the compressed data after the encoding, right? And compresses raw signals into a digital format, and this is kind of decoding, modify and re-encoding an existing file. The first step is a digital flow. This compatible for this, right? To make file small enough to store and send, okay, to ensure it works on all devices and network speeds, right? This is the primary goal. This is the takeaway, the difference between the two. Yeah. Okay. Okay, so transcoding, right? So transcoding, we will have to have some kind of a transcoding service as well here. Service. Yeah. And it can keep talking to it. Sorry. Yeah. Okay. Yeah. I think this is else. Anything else missing in this diagram, right? You may also want to involve some kind of an analytics, right? So let's say you want to see how the, or let's say as you were saying, right, some few people, we can have what the transcription and all of that, right? So what can happen is with this data itself, right, with this data itself, or this media serve, I mean, if it has to be transcription and all of that, this would be the input for that. Okay, and you can later on generate and have different files for it, right? But if it is, let's say, for some kind of an analytics, right, I somehow feel that we can involve analytics in every system design. I mean, when I say every, I mean most of it, right? For and all these packets would be coming somewhere from the media server, right? And let's say when we send this to some kind of analysis server or something, right? Analysis service, or not analysis, it would be analytical service, analytical service. Okay, and from here you can actually send it to some Kafka again on some topic. Okay, so let's say this will be, I can call this as some kind of a metrics or something. Okay, sorry, metrics. Okay, and this I can have some kind of a consumer service, which can be some kind of a Spark job or something. Okay, which takes this and then let's say stores in some kind of a table, and let's say some kind of a time series DB or whatever you want to have. You can have, like, let's say what, there is something called OpenTS, right? Open time series, right? InfluxDB is one, right? These are some of the examples you can. Yeah, I think this is what you can think of. Yeah, this was WebSocket registry. Okay, any questions? If not, we'll just again summarize this. As I always say, that before you end the interview, right, you have to summarize to the interviewer to so that he takes some kind of an impression, right, before he leaves the call, right? We discussed about these functional requirements. Don't talk about this. These are the APIs, right? We talked about the WebRTC, right? Where we talked about the different components in it, right? And you can probably read about this, right, from Hussein Nasir's video, right, about WebRTC. If we have to have a group call, right, we can have this kind of a mesh configuration, right? But it can only go to certain extent. Let's say we say n is equal to 10, right? So until n is equal to 10 number of users, we can have this, we can support this, right? Beyond 10, we'll have to probably go with this kind of a configuration, right, where a media server is involved, right? When then we jumped into the high level diagram, but we kind of edited the same diagram. We should have copied this. So this was these are the client, these are the API gateway, right? All we can draw arrows from here, right? This entire component, right? This entire component that you see here, right, is kind of under WebRTC. Okay, so either I can pull this, but the arrows will be all misaligned, right? So let's not draw that. So this will be all under WebRTC, right? And this will be a transcoding service, right? Yeah, all of that. And then end a meeting, some kind of a trigger would be there. File creator service will be invoked. It will get the data from this distributed storage and create a file, put it to S3. And this is a media server broker, which is actually managing multiple media servers, because it may happen that one of them is actually connected to this media server, the other one is connected to other media server. I mean, we have to scale, or there are other meetings that are happening, or we can probably do this based on some kind of a meeting ID, that all the participants for a given meeting ID joins the same media server, right? So this also can happen, right? So this is a recording service. Yeah, this is for analytical service and all of that. Yeah, that's it. I'll stop the recording just in case if anyone has any questions.
Keep
Hey, Pallavi,
seriously
you joined.
and